Go ahead. 11-1, 11-2. Wednesdays, it's a late start day. It's also pretty short lesson. Quiz review Thursday, quiz Friday. End of the 9 weeks after Friday. All right. So 11-1. There's a lot of problems on your guided notes, but they're not that difficult and don't take that long to complete. So a couple things we need to remind ourselves. Let's get going. A couple key terms. Do we recognize the word circumference? Yeah. Distance around the outside. Diameter, yeah, obviously. Radius, yeah. All right. So we know the circumference of a circle is the distance around the outside. Do not say that's 360 degrees, right? Do you agree it wouldn't make any sense to say, oh, how long would it take or how far would it be to walk around that circle? 360 degrees. No, it'd be like 10 feet, 20 feet, something that's a linear measurement. Do you agree? A distance of some sort. Have we seen this formula before? Pi times the diameter. Have we seen that before? Or 2 pi r? Have we seen that? Okay. That's the formula to find the circumference of a circle. All you need to know is the diameter or the radius. Okay? Diameter or the radius. So we have Pi Day coming up. Do you guys know about Pi Day? Pi Day? We'll probably have to celebrate after the state test, unfortunately. March 14th. 3/14. Because of the 3.14. All right? March 14th. So yes, we approximate pi to be about 3.14. We know it goes on forever. 3.14159265 so forth. So if you ask how do you find pi, what's the operation happening between pi and d? Multiplication. So to get pi by itself, I would divide by d. So pi is actually c over d. In any circle ever, if you take the circumference and divide by the diameter, you'll always get pi. That's where it came from. That's how people discovered it. All right? Circumference divided by diameter. So let's do a quick calculation. And we're going to be answering two different ways. One's called in terms of pi, and the other one is rounded. Okay? Now I need you guys to kind of listen. All right? This is important. Somebody's going to ask me about this later, and I'll say, oh, explain it. Make sure you pay attention. Pi is a number. Pi is a number. So if I say 10 pi, do you see how I don't have to round that number? Do you agree? I don't have to round that number. It's what does it tell me to do as an operation? 10 times pi, right? So it's about 31.4. If pi is 3.14 and I multiply by 10, isn't it about 31.4? So this is my answer called in terms of pi, and this is my answer when I actually multiply times pi and I round it to the nearest tenth, hundredth, whatever I'm asked to do. There's two ways to write our answers. In terms of pi and as a decimal. So part A, find the circumference of a circle with a radius of 9 centimeters. Well, let's plug it into our formula. C equals, it's either pi d, pi times d, or isn't a d 2 r's? Isn't one diameter 2 radiuses? 2 radii. So the other formula is 2 pi r. We kind of separate the 2 and the r because we put the numbers out front. 2 and pi are numbers. And the radius could be a variable, but in this case, we're told the radius is 9 centimeters. So for this circle, 2 times pi times 9. Give your answer both in terms of pi and rounded to the nearest hundredth. So my answer here would be, what if I want to write it in terms of pi? My answer would be, I heard someone say it, 18 pi, yes? Centimeters or square centimeters? Squared or regular centimeters? If I walk around the edge of a circle, would I walk around it 10 centimeters? That's a small circle. Or 10 square centimeters? Centimeters. Squared is telling you it's an area. I'm not finding the area of the circle, finding the distance around. Out.
Is pi short for something, or is it just a really short word?
Pi is actually a letter in the Greek alphabet. So it's a symbol to us, but it's a letter to the Greeks. Alpha, beta, gamma, pi, like so forth. And actually 2 pi has its own letter as well. I think it's called rho. R-H-O. All right. 10 pi or 18 pi, excuse me. And we also want to write our answer to the nearest hundredth. Anybody typing that in? 56.55. So use the pi button in your calculator, okay? 18 times, do you guys all see the pi button? 56.55. 56.55 centimeters. One of those answers is nice because it doesn't have any decimals in it. The other answer is nice because it actually tells us how far you actually have to walk around whatever it is you're talking about. Make sense? All right. How about letter B? Well, they're asking us to find the radius. So isn't C equal to 2 pi r? And what did they give us? The circumference was 26. I'm going to plug in 26 for C and solve for R. Good. How do I get R by itself? Divide by 2 pi. Good. Divide by 2 pi on the right side. Divide by 2 pi on the left side. So R is 26 over 2 pi. I would be okay with that. Isn't that the same as 13 over pi? Yes. 26 divided by 2 is 13. Pi is still in the denominator, right? That would be in meters. Or, if they ask me to round, I actually take 13 divided by pi, and I get 4.14. 4.14 meters. Make sense? Are you guys getting the same thing I'm getting? Awesome. Move on. Arc measure. So it was important we found. Yes, McKay.
The last one, do you always have to simplify it to 2 pi divided by 6?
Yeah, I said I'd be okay with the 26 over 2 pi. I think the 13 over pi is the neatest, but I wouldn't be that picky, I don't think. Well, some grading Jackson's quiz, it might be that little different. We'll see. Arc measure. All right. Arc measure versus arc length. We talked about this a little bit. If I say I'm going to walk around the whole circle, I have walked a full 360-degree rotation. Doesn't arc tell us rotation of the circle, right? Remember the central angle and the arc measure were the same. Can you hear the difference between arc measure and arc length? That's more of a how far did you walk question. Not what portion of the circle, not 90 degrees. 90 degrees, but oh, you just walked a fourth of the way around that circle. But it doesn't tell us distance, does it? Right? But if I say 10 feet, 20 feet, that's an arc length, okay? So be careful when you're reading these. How much of the circumference is the arc? Okay. So what's a full rotation around a circle? 360. What's the full distance around a circle? What's the full distance?
Great. Pi times.
Pi times diameter? Or 2 pi r? That's the circumference. Isn't that the distance around a circle, right? Distance, circumference, synonymous, okay? So we're going to find arc length today. So this looks like a really confusing fancy formula. Please pause what you're about to write and just look up here for a second. I think I actually even didn't make you fill in the blank on this one either, right? So just look up here. All eyes up here. Do you agree if we wanted to find the circumference, we would do 2 pi r? What if I wanted to find half the circumference? Wouldn't I take half of 2 pi r? What if I want to find a fourth of the circumference? Wouldn't I do a fourth of 2 pi r? An eighth of the circumference? So guess what? If they tell us that we want to find an arc, or we want to find the arc length. Okay, I think we're visual. Most of us are visual. Let me draw it for you. All right, here is a 90-degree angle. What is the measure of the arc in degrees? Right. What is the measure of that arc in degrees? The blue arc. Not length, measure. If the central angle is 90, what's this measure of this arc? Careful. 90. Central angle and the arc are the same. Ooh, that sounds like last week. It is. Okay. Second question. What fraction of the circle, if I not in degrees, what fraction of the circle did I walk around the circle? Did I walk around? A fourth, right? A fourth. Is it 90 over 360 a fourth? Okay. So that's where if you plug in 90 for arc AB, isn't 90 over 360? Look up here. Look up here. Isn't 90 over 360 going to give you a fourth of the circumference? A fourth times the circumference? See, it's kind of baked into the formula, okay? Like, look, here's another one. Let's do halfway around the circle. Here's arc AB. Isn't that a 180-degree arc? What's 180 over 360? Half. Half of the circumference would find half the distance around. Okay? So here, when you have to memorize this formula, don't overcomplicate it. If you want to find the length of an arc, the arc length, you're going to take the arc measure and divide by 360 to find out what fraction of the circle you're going around times the whole circumference, right? Page.
Would we ever use like pi times diameter instead of 2 pi r, or is it always going to be 2 pi r?
You could use pi times d there. It doesn't really matter. Yeah, either one's fine. Does that make sense that you're finding the fraction of the circle, the fraction of the circumference you're calculating? And you take the arc over 360. I'll take that as yes. All right, moving on. Find arc length AB. Do not say 60 degrees. That is not an arc length. That is the measure of that arc, right? So the measure So arc AB, well, we have some degree measure over 360 times 2 pi r. I'm going to just play a little fill in the blank game here, Okay, all you need to know is the arc measure and the radius. What's the arc measure that we're finding in degrees? 60. And what's the radius? 8. There's our fill-in. So what is, not that you need to do this in your head, but what's 60 over 360 as a fraction? 1/6. So guess what portion of the circle we're walking around? 1/6 of the circumference, aren't we? 1/6 of the way around the circle. So if you type this in, we're going to give our answer in terms of pi and as decimal. Make sure you're putting parentheses around the 60 over 360 if you're typing it in all at once. And so as you go to do these on your own, if it says in terms of pi, this is another thing I guess I have to teach you, okay? When it says in terms of pi, guess what I'm typing in my calculator? Everything except for the pi, okay? So 60 over 360 times 2 times 8. And that gives me the 2.6 repeating part, and I left out the pi. So that's 2.6 repeating times pi. Now that's kind of an ugly decimal. We could write that as a fraction, okay? Now, leave the 2.6 repeating in your calculator and then times pi to get our answer as a decimal. .38 centimeters. So this, if you're a fraction person and you'd rather not have that as a decimal, that is 2.6 repeating is 8/3. That's probably the cleanest answer in terms of pi. I'm not going to do that to you that often, but you guys know the fraction, the decimal to fraction button you have in the calculator? If you leave the 2.6 repeating, okay? Yeah, second PRB will get you a decimal to fraction. You can convert it to 8/3. All right, you try the next one. I think, sometimes I don't like their diagrams. I think that 9 is going to the radius. Would you agree? I don't like the way they draw some of these diagrams. Use 9 as the radius. Use 9 as the radius. Did you use 9 as the diameter?
Yes.
I understand why you would. Did you get 11.78 yards as the decimal?
Yeah.
11.78 yards. Meaning, if you walk from P to Q, you just walked 11.78 yards. If the the radius is 9 units, right? Questions on that? Now, in terms of pi answer, 15/4 pi or 3.75 pi. Now, where does that pi belong? This one. Does it belong with a 15 or with the 4 or both? Like, would it be in the top, would it be in the bottom, or top and bottom? Should pi, if I'm thinking of it as a number, which it is, would pi be with the 15? Would it be with the 4, or would it be with the 15 and the 4? How about that? 8/10 times 3. Is the 3 with the 8, with the 10, or with both? If it's with both, then it would be 8 times 3 over 10 times 3, which is 24 over 30. Or 8/10. Is 8/10 times 3 8/10? No, so it can't be with both, right? If it's with both, it would cancel and make 1 every time. Yes? Can't be with both. What's another way to think of 3? 3 over 1, so it's 8 times, it's with the 8. 8 times 3. Yes? Isn't pi a number very similar to 3? So couldn't you write it as 15 pi over 4?
Yeah.
You could. I don't expect you to. But you're going to see that in later math classes, so a little foreshadowing today. All right, find the circumference. All right, this one's a little tricky. What did they give us? They gave us the angle measure, the central angle measure, and the arc length from X to Y. So, isn't arc XY equal to 40 over 360 times 2 pi r? Yes? Isn't that the formula for arc length? And what did they tell us? I didn't fill one part in yet. They gave us the arc. Good. So 4.19 is the arc. So 4.19 equals, and I'm going to go ahead and take this minute and reduce. What's 40 over 360? 1 over 9 times 2 pi r. What am I trying to get? What am I trying to solve for? I'll accept 2 different answers here. I could find r. And I bet the robot in us, okay, your inner robot, you know what I'm talking about. We get to be math robots sometimes where we're like, solve for variables, don't stop until you've solved for a variable, right? And we just kind of become robotic and we just do a process because that's what we've always done. Yes?
Yeah, sure.
Beep, beep, boop. Yep, and then we turn into little robots. Okay, too early for a Monday. All right. Or we look ahead and we say, I'm trying to find the, give it an answer, you have an idea? I'll hold off 1 second. Or we could say, I'm trying to find the circumference, and circumference is 2 pi r. So if I could get this 2 pi r by itself, I'll have the circumference. Do you see it? Capital. Wow, tough crowd. All right, so I should multiply both sides by 9. By 9. So 4.19 times 9, 37.71 equals 2 pi r, which is the circumference. 37.71 inches. Tally.
How many pages of pi do you know?
Not many. Not too many. We used to have a competition to see who could memorize the most.
I think we should do that for like bonus points, like extra credit.
I don't recognize these words, bonus points for extra credit. Now,
Yeah.
all right, what if?
You ever heard about it?
What if you solved for a radius? If you solve for the radius, then you just plug it into the circumference formula, you get 2 pi r, and you should get the same thing. And you'd be like, I could have just stopped at that point. Maybe not. Maybe the robot wouldn't recognize that. All right, you try. So that's 61.26 meter arc. That length is the big arc.
Oh, the whole thing?
Yeah, the big one. L K M. Now that one I'm not trying to be like rude or anything. I actually think that one's okay to be labeled that way. I am picky with them for how they label certain things. But if they're giving us a 270-degree arc, they would have to be giving us the whole arc in blue. They couldn't just give us a portion of it, or we wouldn't even know what the other portion is. You guys get 81.68? Come on. Yeah. Yes.
You're wrong too.
Well, no, I'm following what he did. I'm confused. So you just took the 2 pi r and just changed it into the circumference?
2 pi r is circumference, yes.
Okay.
Did you go robot on me and solve for r?
Well, the rubber on me was too.
I understand. All right, if you didn't recognize this up here as 270 over 360 is 3/4, you could have multiplied by both sides by 360 over 270. Same result. Just put parentheses around it when you do that. Do you agree 270 is 3/4 of the way around the circle? 3/4 of the way around the circle. All right. We're getting there. You guys want to do another one of those, or are we good? R, S. Yeah, they gave us the radius here, and they gave us the arc length. What are we going to have to find? Now, we better do this one. This one's a little different. What is this? Just look up here for a second. What is our final answer? The unit. What are the units going to be measured in? No.
Degrees.
Degrees. Very good. It's not not asking us to find the length of RS. Guess what? We already have the length of RS. They gave it to us. That's the length of RS, isn't it? We want to find the angle, or because it's a central angle, the arc measure. The measure of the arc in degrees. Well, let's plug it into our fancy dancy calculator. Well, formula first, and then calculator. All right. Isn't our arc length 44 equal to the measure of the arc RS in degrees over 360 times 2 pi, and the radius is 15.28. Are you with me? We're trying to solve for that, the arc measure in the numerator up there. What should we do? How are we going to solve for that? By the way, everything over here is multiplication. That's good news. What'd you guys do first? Would you simplify that?
Yeah.
Would you guys would you simplify everything here in blue? Be honest with me. I need your help. Yes?
Yes.
Okay, because I would do it. I sometimes do things differently than you guys do. All right, so 44. All right, if you do 15.28 times 2, you get 30.56 pi. Would you guys divide that by 360?
I divided the 30.56 pi by 44 and then multiplied it by 360.
Okay, so do you agree we could divide this side by 30.56 pi if we divide this by 30.56 pi? Yes? What does that cancel? That. So 44 divided by parentheses 30.56 pi, and you may not need parentheses. I'm just being careful. I'm getting 0.4583. Now, I'm rounding it so far because I'm going to have to do another calculation, and I don't want it to become more and more off, okay? That equals the measure of arc RS over 360. So my last step is to multiply both sides by 360. So I actually left that decimal in my calculator, even though I rounded it up here. And I'm just going to do times 360. And I get 164.99 degrees. Okay.
Never mind.
You sure?
Would it be okay if we rounded to 165 degrees, or should we leave it with a decimal?
That's really close. I mean, that's 1/100th of a degree. I'd be okay if you rounded 165. It didn't really tell us, so I usually round to the nearest hundredth just to be safe. All right, there's other ways to do it. All right, and I don't want to confuse you, but you could see everything in blue. Remember how we practiced a couple minutes ago? We said, is it with the numerator, or is it with the denominator, or both? Isn't this really over top of 1 over here? So couldn't I divide what's in blue here right now and get a decimal and then divide that on both sides? That's fine too. Okay, if you don't want to break it up into pieces. You're only doing this when you're trying to find the measure of the arc. The measure of that arc. This is not an arc length problem. Look, I know the arc length, 44 meters. I know the radius, I'm just trying to find the measure of that arc in degrees. Okay? All right, I want to get to another type of problem for you guys to make sure we're okay with this. All right, the dimensions of a car tire are shown. How many feet does the tire travel when it makes 15 revolutions? Well, have you seen this before, where you you put a point on a tire or on a wheel of some sort and you roll it, and once you get, I guess typically you put it on the bottom of the tire, I guess, to start. Like if you put it on the bottom of the tire and you roll it until that point hits the ground again. Have you ever seen that happen?
No.
What's that length called? It's the circumference, isn't it? Isn't however long it takes, how many feet or inches in this case, when this rolls to get back to the blue dot being on the bottom, wouldn't that be called the circumference? That's called 1 revolution. So our task is to find out how long is 15 circumferences. Do you get that? That's really what it's asking. Find the circumference and multiply by 15. Well, we got some math to do here. What are they giving us? They're giving us the rim diameter. They're giving us the sidewall. It's called the sidewall of a tire. Sidewall distance. Okay. So isn't that all combined, just the diameter, right? That's just the diameter.
Yeah.
What do you get when you add them up? 26. So the diameter of this circle is 26 inches. So C is it better to use pi d or 2 pi r in this case? Pi d. Pi times d. Pi times 26. So we're going to multiply that by what? We don't want just one of those. We want 15 circumferences. So if I multiply 15 on the left side, I multiply 15 on the right side. 26 times 15 is 390 pi. And that's in feet. Now, that doesn't mean anything to us. That doesn't mean anything to us because... Oh, hold on, that's inches. Inches, my bad. I'm getting ahead of myself. What did it ask us? It asked us how many feet does it travel. So we're going to have to convert. Right now it's in inches. Do you agree? 390 inches. Well, let's actually multiply 390 times pi. I'm getting that's approximately equal to 1,225.22 inches. That's how many 15 rollings of the tire you get, okay, revolutions. So to get it in feet, we divide by 12. That's 102.10 feet. Okay.
Why did you do 390 pi equals 15? Like, I don't get why you did that, because I did something else, but I got the same answer.
Yeah.
Okay. 1C was 26 pi. 15 C's is 390 pi. I multiplied by 15. They asked us 15 revolutions. So not just one circumference, 15 circumferences.
Yeah, I just did the circumference times what? Yeah, times 15.
Yeah.
So
Yeah, that's what 15C means.
But what's the 390?
That's 26 times 15.
Okay.
Page.
Can I just show it as like circumference equals pi times 26 times 15?
Times 15. Yeah. I just multiply both sides by 15.
Okay.
If you did it the same way, I'm not real picky on that. Questions? All right. And then a problem like this, the curves at the end of the track shown are 180-degree arcs of circles. The radius of the arc, and actually this has really interesting implications. Who are my track runners in here? Okay, this is why they stagger a start for anything above what? 100 meters? Anything above 100, because 100 is a straightaway, isn't it? Anything above 100, you have to stagger the start because the inside of the track is going to be shorter than the outside, right? Get that? All right, the curves at the end of the arcs shown are 180-degree arcs of circles. So this to this would be 180 degrees, okay? The radius of the arc for a runner on the inner path shown is 36.8. From here, this is the arc for the inner runner. About how far does the runner travel in one lap? Okay. We're going to run out of time for this one. Do you see how it gives you the radius for an outer runner and the radius for the inner runner? Okay. Do you agree? The plan here, we don't have time to actually do it, but the plan would be to find that arc, which is the same as this one over here. And isn't that half of some circle? So find the length in meters of that one and double it, because there's two of them. And then find the inner runner's arc from here to here and double it. And aren't they both going to run that straightaway of 84.39? Yes. So you'd add those to it. So you'd actually find the, I wouldn't call this circumference because it's not a circle, but the track circumference, I guess we call it, for the blue and the red, and then compare them. And that's how you find out how much to stagger the start by. Interesting, huh?
Is there gonna be a problem with the homework? Because I don't really understand.
I'll show you in a minute. All right, homework, page 586. Let's see, make sure it's the same as this. Yep. They're in.
They are?